Hello, Math 3 students. So today we are going to go ahead and talk about how we evaluate trig functions when we are given a point on the terminal side of the angle. So if we take a look here at number 1, what I would recommend doing is drawing a coordinate plane and plotting the point that they give you. So we are plotting 8, negative 8 root 3. So 8 is going to be in this direction, negative 8 root 3 is in this direction. So we have a point in this quadrant. Really, it's just important to know what quadrant you are in. So then we can draw a line to the point. And what you're going to do is make a right triangle by drawing a line from the point to the x-axis. It might be, you might have to draw it down, you might have to draw it up. Like if we're in the first quadrant and we wanted to do that, we'd have to draw the line down to the x-axis. But you just want to draw that line to the x-axis. And then label the sides of the triangle that you just drew. So here is 8, and this guy is 8 root 3. And they are asking us to identify cosine of theta. So we can mark, so theta is always going to be with respect to the x-axis. So after you draw that line down, draw in theta here. And we know that cosine of theta is always equal to, right, remember SOHCAHTOA, S-O-H-C-A-H-T-O-A. So cosine is always adjacent over hypotenuse. So if we look at the theta we just drew, we can see that our adjacent side is here by 8, and our hypotenuse is going to be this side here. Now, we don't have our hypotenuse, so what could we do to find that? We're going to go do Pythagorean theorem. It's a right triangle, right? So we'll do 8 squared plus 8 root 3 squared equals, and then we could just put like x squared because that's our hypotenuse. One thing I want to caution you against, when you square something that has a radical, you need to make sure that you put parentheses around the first coefficient there and at the end. Or else if you just type it in like this, your calculator only squares this guy and you're going to get the wrong answer. So you have to use those parentheses. So make sure you practice this with me so that you don't plug it in wrong to your calculator, because then you're going to get Pythagorean theorem wrong, and that's annoying. So we're going to do open parenthesis, 8, and then I've got the square root of 3. On these newer like 84s, I have to arrow out to close that parenthesis, and then I square it. So I get that this is 192. And obviously 8 squared is 64. So I add these together, and I get 256 equals x squared. So what I can do now is just square root both sides. Now this is a perfect square. You always want to check to see if it's a perfect square. If it's not a perfect square, then you're going to have to simplify the radical by using perfect squares. But in this case, it is a perfect square, so it makes our lives nice and easy. And our hypotenuse here is going to be 16. Oh, and you know what? This is something I 100% should have included. When we went down 8, I should have made this a negative 8 root 3, so make sure you go back and fix that. All right, so at this point, we have all 3 sides of our triangle. And we can definitely find cosine of theta. So cosine is adjacent over hypotenuse. So in this case, my adjacent is 8, my hypotenuse is 16, and I can reduce this down to 1/2. So that would be my answer here. One thing I want to point out is when you're doing these, you have to pay attention to the signs. Like had I found cosine of this, okay, like let's say I wanted to find sine of theta in this case. That would have been opposite over hypotenuse, which is negative 8 root 3 over 16, which would reduce down to negative root 3 over 2. So I'm just pointing out to you that like the signs in this case matter. So make sure that when you draw your triangle, you include the signs, because that's going to have an impact on your answer. All right, let's see. So this one, we can draw our coordinate. We're going to go plot 3, 4. So that is just in the first quadrant here. 3, 4. We can draw in our triangle. Remember, the right angle of the triangle needs to touch the x-axis. And we can put in theta here. And they want us to find sine. So what I'm going to do here is I can go do Pythagorean's theorem, unless if you know your Pythagorean triples. You could probably just do this in your head. So we get 9 plus 16 equals x squared. 25 equals x squared. I get that x is equal to 5. So that's my hypotenuse. And sine of theta, we know, is opposite over hypotenuse. I get 4/5. All right. Let's see. So here we've got, let's see, if theta has a terminal side on 5, -5. So we got to go plot that point. Or sorry, -5, -5. So I'm going to go -5 in this direction and then -5 in this direction. I can draw my hypotenuse. I have to make my right angle with the x-axis, and I can write in theta. Then I can go do Pythagorean's theorem. Additionally, if you know your special right triangles, like this one, you could have just, looked at this and be like, oh, it's a 45, 45, 90. This is going to be 5√2. But yeah, I'll do Pythagorean's theorem still, though, to show you guys. Your hypotenuse is always positive, so keep that in mind when you are, finding your hypotenuse. But obviously, the x and the y coordinates can be positive or negative depending on the quadrant. So I do -5 squared plus -5 squared equals x squared. I get 25 plus 25 equals x squared. 50 equals x squared. And I take the square root of both sides. Now, when I go to my calculator to take the square root of 50, I do not get a nice answer. So that tells me I have to break down the radical using perfect squares. So hopefully you remember those. If you don't, you can always generate a list. So we have like 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. You could keep going higher. And the way I get this is just doing 2 squared, 3 squared, 4 squared, 5 squared, and so on. So now I have to find the biggest perfect square that divides into 50. So I would try every number less than 50. So I could start with 49. 49 doesn't divide into there. 50 divided by 25, that does. So I break this down into 25 times 2. That 25 comes out because I can square root it, and I get 5√2 is x. So that's where we get that hypotenuse there. But obviously, like I said, if you know your 45, 45, 90, you also could have just done that. Okay, so now we need secant, okay? Well, we know that secant is cosine's buddy. And we know that cosine is adjacent over hypotenuse. So secant is going to be equal to hypotenuse over adjacent. Remember, secant is the reciprocal of cosine, which means that you take cosine and you flip it. So I can go and find cosine of theta, and I can label, this is my opposite, adjacent, hypotenuse. So my adjacent is -5, my hypotenuse is 5/√2. So when I go and find secant, all I need to do is flip it. So then in this case, we have to look, I should say just like in general, we have to look and make sure that we simplify and rationalize if necessary. So in this case, we can simplify. The 2 5s cancel. We still have that negative though. So the final answer here would be -√2. All right, let's try, all right, let's try this one here. So we're gonna go ahead, draw in our triangle. We go 4√3, -4. So that's gonna be in this quadrant. You can draw that line in, put in the right angle, and put theta here. Now in this case, the only reason I knew that this one is a 45, 45, 90 was because these are congruent. Any congruent right triangle is, or any isosceles right triangle is going to be a 45, 45, 90. Now in this case, even though I have a √3, I have no idea. But actually, I guess in theory we do know that this is going to be a 30, 60, 90 if we look at the 4 and the √3. But this is a little bit harder to spot, I will say. So I'll, of course, still go through and show you how to do Pythagorean's theorem. So we're going to go ahead and do, actually, we don't even have to do Pythagorean's theorem here because we don't need the hypotenuse for tangent. So for tangent, right, we know that TOA is opposite over adjacent. So we've got opposite and adjacent. So we just have to do -4 over 4 root 3, right? Because that's our opposite over adjacent. So then when I simplify this, I get -1 over root 3. Well, we all know there's a problem with this. We got to go rationalize. So I do over root 3, 3 over root 3, and I rationalize. So I do -√3 over 3, and that is my answer there. So go ahead. Why don't you try this one and this one? I would like for you guys to give that a shot before the next class.